flash, not the fake flash.
Okay. We need to get a common denominator. Driving? Me? Crazy. Okay. We drive by 4. Drive by 4. You're frustrating me. 5x. It's all being recorded. It's a problem. Okay. So.
You're nailing it.
Yeah, it's solid class. Solid class. Okay. So we are going to distribute the top, and we get 12. And make sure we have equal signs. If you don't have equal signs, put them in. So we're going to go 12 over 20 at x plus 7x times 5x, which is 35x squared, over 20x. Now, paying attention. 20x in the bottom we put together because both denominators were monomials. So when both denominators are monomials, we put them together. When one is a monomial and the other is not, we don't. Okay? So both these are monomials, and that's the only reason why we're putting them together. We have a common denominator, so we write it over that. And we're going to go...
So why didn't you put the 20 and the x in their own brackets?
You can. It doesn't matter.
Okay.
Yeah. So we're going to get 12 plus 35x squared. Now this is where people go astray. You're done.
Yes.
You guys keep going, which is a problem, okay? So let's think about it this way. So what we do is, like Kyle had said, why wouldn't we put these in brackets? We can. And then this whole top can go in brackets, correct? Because it's attached by a plus sign. So the only way it's going away at this point is, can I take something out of both of those? Which I cannot. Does it match something completely on the bottom? No. Can't make it any better than that. That is as good as it gets, okay? So the problem doesn't lie in you guys actually doing addition and subtraction. The problem lies in you wanting to simplify more at the end, okay? And then at the end, we have to go x cannot equal 0. All right. B, quiet please. B, you need to have a common denominator. Well, I already gave you one, okay? So you can rewrite it over one denominator, x plus 2, and you can put it in brackets or not in brackets, it doesn't matter. But putting it in brackets might make you not simplify off things that you can't. Okay, so I'm going to put it in brackets. The top, I have to remember that I can put it together, but I have to remember to subtract both. So I'm going to get minus 5x minus 3. And I told you that if you don't remember to do the 3, they will have the answer to that there. Correct? They will, because it's common error 101. So now we can collect like terms. 4x minus 5x is negative x, and then there's just a 3 sitting here, minus 3 over x plus 2. Now, we have negative x minus 3. Can I take anything out of that? If I wanted to, I could take a negative 1 out, but would that help me simplify it? No. They might want to be able to do that just in case they actually have that as an answer. All right, so x cannot equal what? Negative 2, we're done. So honestly, I'm telling you where you guys make errors is you want to simplify more than you can, okay? Now 3, they look very similar, but they're the wrong what? Sign. And when they're the same but wrong sign, I can make them the same by? Or just taking out a negative 1. Either way would work, okay? So I'm going to take a negative 1 out of this one, and I'm going to be left with negative 3 plus x. Or you could have multiplied the top and the bottom by negative 1. It does not matter. Same thing. Okay, guys? So we're going to get, if you want, you can bring the negative up, or you can leave it on the bottom. It doesn't matter. I'm going to multiply this one by negative 1. I'll show you if you multiply them by negative 1 on the left or the right, you're going to get the same answer in the end, okay? So don't go changing your answers. So we're going to get x plus 3 over negative 1, x minus 3. So that could be one answer that you could have, okay? The other answer that you could have is this negative 1 could have moved to the top because you decided to multiply by negative 1. And the other answer you could have is negative x minus 3 over x minus 3. Both of them are correct. So I don't care which option you have. You could have this option, or you could have this option. Both are correct. You could take a negative 1 out, and you could actually have this. That is also correct. All three of these are correct. Yeah.
How do you get the negative x? There's 3 answers.
The negative x here?
Yeah.
By bringing the negative one to the top and distributing it through.
Do you have to multiply or anything, or is it just...
So if I put the negative 1 through, I get negative x minus 3.
Okay. So do you...
So then on a test, like let's say this is a multiple choice question.
Yep.
Will one of the three be on there?
Only one, yeah.
But then, what if you get, like...
You have to know that you can move the negative 1 around. So you could, if there's a negative 1 on the bottom, you can bring it to the top. You could leave it out front, or you could distribute it through. You need to know that you can move that negative around because all three of these are correct, and all three of them could be there. And they can't cancel because they don't match. X cannot equal 3. So this one, or any of those three versions, right? If it's a written response, you're good for all of them. I would have to mark all of them correct. All right. B. This is the standard of excellence. Why is it a standard of excellence? Because I don't just multiply my denominators by each other, right? What I can do is, for the bottom left denominator, it's a what?
Yeah. Oh, like...
Difference of squares. So I get x plus 2, x minus 2. The bottom right, I can do what? I can GCF out a x, and I'm left with x plus 2. So it's a standard of excellence the moment when I have to take those denominators and actually simplify them first before making a common denominator. Okay, that pops it into the standard of excellence column, which doesn't always mean harder. For example, 3 Venn diagrams are standard of excellence. Any 3 Venn diagram is a standard of excellence. Okay, so not way harder, just standard of excellence. All right, so both of these share in common an x plus 2. This one has an x. Now this is the thing, people will say, well, I can just multiply it by negative 2 and then I have x minus 2. No, if you multiply by negative 2, you actually have negative 2x, because that's multiplication, right? So when these look the same, they're not. You have to still just multiply them by each other. You can't make a monomial, which is this one, be a binomial, and you can't make a binomial be a monomial. Remember I told you that? You can't make a single term be a double term, you can't make a double term be a single term. So you have to just multiply them by each other. So I'm going to multiply this one by x, and this one by x minus 2. So on the top, we're going to get x squared over x plus 2x minus 2. And then plus, and I have to distribute this one through, so I get 3x squared minus 6x over x plus 2x minus 2. So now I have common denominators, right, Code?
Indeed.
Indeed. So we can write them over one denominator. So we can go x plus 2, x minus 2. And then I write my whole numerator, x squared. When I have a plus sign in between, does that affect anything? No, it's only when it's a subtraction or a negative. We have to distribute it through, right? So we get x squared plus 3x squared minus 6x. My next step is always to collect like terms. So I'm going to get 3x squared plus x squared is 4x squared minus 6x over x plus 2x minus 2. So I've literally finished all of my addition and subtraction stuff, right? I collected like terms. I have my answer in the end. So once I've collected like terms, I have my answer in the end. I told you there's one extra step we always have to check in the very, very end. Can I simplify? Can I do any simplifying like I would have done in the very first lesson where I have a rational? Just what? Something over something. Can I do anything? Yeah, in the top I can take out a what? A 2x. Take a 2x out, I'm left with x minus 3. And the 2 and the x can be in their own brackets, right? Over x plus 2x minus 2.
Oh wait, how's that not to like...
Should we do it
Yeah. 2x minus 3. Just 1, 2 times 2.
Good call. 2x minus 2. So, if nothing canceled, this would still be more simplified, correct?
How do you simplify that? Just made it a little more complicated.
Yeah, well, because you haven't taken out. So at this point,
What's the point of doing that?
just wait. At this point, if it said simplified, we couldn't cancel anything off, we would be done because we've actually simplified, correct? But what can we actually cancel off here?
Yes.
The x. Now, before I cancel, what should I have done? Stated NPVs, non-personal values, or restrictions, right? So my NPVs are x cannot equal 0 and plus or minus 2. I have to state NPVs before I cancel, not after, or I'm wrong. So in the end, I have 2 bracket 2x minus 3 over x plus 2, x minus 2. X cannot equal 0 or plus or minus 2. Okay? The next one's a standard of excellence again. Why is it a standard of excellence?
It's hard.
It's hard because I have to do what first? I have to take a difference of squares out before I make a common denominator, right? If you have a phone up, put it away. So, bottom left is a what? Difference of squares. You have to stop yourself from doing this. In the numerator, you guys will try and take an x out. And you'll write x and x plus 3. You'll try and, remember, we only do that. We only simplify our numerators and our denominators. Make it go away. We only simplify our numerators and denominators if it's multiplication, division, or simplifying, correct? When it's division or when it's subtraction and addition, we only simplify our denominators. That's it. Don't take a GCF out of the top. Stop yourself when it's addition and subtraction. Because if you take it out, you're going to have to put it right back in. Okay? So we're going to rewrite our numerators. And we simplify only our denominators when it's addition and subtraction. So we get x minus 2, x plus 2. Plus x squared plus 5x. I do nothing to that. And I get x plus 2. Now what's common to both of these denominators? X plus 2. Your left-hand side has x minus 2, and I need to make my right-hand side have that. So I'm going to multiply by x minus 2. Because I have a binomial times a binomial on the right-hand side, what am I going to have to do? Distribute by using FOIL. So first, outer, inner, last. Try and do it backwards, facing it. Okay. So this one just stays the same. X squared plus 3x over x minus 2x plus 2. This one I distribute. So I get x squared times x, which is x cubed. X squared times negative 2, which is negative 2x squared. Plus 5x squared. Minus 10x. All over x plus 2x minus 2. Same denominator, so I can write it over it. And my whole numerator I can write together. So x squared plus 3x plus x cubed minus 2x squared plus 5x squared minus 10x. My next step is to collect the like terms. So x cubed comes first, there's only one of them. So I get x cubed, bless you. X squared minus 2x squared is negative x squared, plus 5x is 4x squared. 3x minus 10x is negative 7x over x plus 2x minus 2. So I've done all of my collecting like terms. I've put them all together. I think I'm done. I want to box it, but I always have to ask myself one last thing. Can I simplify it more? I can take an x out of the top. So I'll get x squared, yep, plus 4x minus 7 over, and that can't factor, x plus 2x minus 2. And then x cannot equal plus or minus 2 because nothing cancels. Okay? Okay, it says simplify. So we're going to do 1 over a plus 1 plus 1 over a minus 1. And then 2, you're going to do 5 over x plus 2 minus 2 over x plus 5. So try these two out. All right, so for this one, we have a plus 1, a minus 1. Now, I gave you this one specifically because people try and make them the same. A plus 1 and A minus 1 is equally as off as A plus 7 and A minus 4. You can't make them be the same. These are the ones that get done the most incorrectly on a test because you guys try and make the denominators the same. You can't. A plus 1 and A minus 1 are nothing alike. You will just multiply each of them by each other. That's it. Okay? So don't fall to trying to make them be the same because in order to make common denominators, we have to multiply. And there's nothing I can multiply both of them by or one of them by to make them be the other one. So I have to multiply them by each other. Okay? So I'm going to get A minus 1 here and A plus 1 here. So I get A minus 1 when I multiply by 1 over A plus 1, A minus 1 plus A plus 1 over A minus 1, A plus 1. Now you have to make sure you don't cross them off. So some people at this point will be like, look, they match, and cross them off. You just put it on. Don't take it back off. So your steps are make common denominator, put the numerator over the denominator, collect like terms. 3 steps for addition and subtraction always, right? Make common denominator, put all over one denominator, collect like terms. Okay? Make common denominator, put over one denominator, collect like terms. Do we agree? Those 3 steps have to happen. One denominator. Okay, we did that. Common denominator. Put over one denominator. Okay. So, common denominator did that. Put over one denominator did that. Collect like terms. Next step. Right? A plus A is 2A. Negative 1 plus 1? 0. Over A plus 1, A minus 1. So with addition and subtraction, it's make common denominator, put over one denominator, collect like terms. Then I'm done. What's my last step always to check for? MPVs, and can I simplify? I can't simplify anymore, so my MPVs are just A cannot equal plus or minus 1. And I'm done. Number 2 denominator, x plus 2, x plus 5. Can I make them be the same? No, they're equally as bad as A plus 1, A minus 1. So only way I can make them be the same is if I actually multiply them by each other. So I'm going to get x plus 2. I'm going to multiply this one by x plus 5. And then this one I'm going to multiply by x plus 2. Do I distribute my denominators? No, because they're not monomials. So I'm going to get 5x plus 25 over x plus 2, x plus 5 minus 2x plus 2, so 2x plus 4. Yep, I was going to distribute it from my already. 2x plus 4, okay, over x plus 2, x plus 5. So first step, common denominator. Second step, write it over one denominator. So I'm going to get x plus 2, x plus 5. So I get 5x plus 25. When it's a subtraction, I have to watch myself. Minus 2x minus 4. Common denominator, write over one denominator. Collect like terms. That's my steps. Always, 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 doesn't change. So now I get 5x minus 2x is 3x. Plus 25 minus 4 is plus 21. Over x plus 2, x plus 5. So I followed my 3 steps for addition and subtraction, which were make a common denominator, write over one denominator, collect like terms. My very last step I always check for NPVs and can I simplify every single time. Can I simplify this one? Yeah, I can take a 3 out. And I get x plus 7 over x plus 2, x minus 5. And then I go x cannot equal negative 2 and 5. So, make common denominator, put over one denominator, collect like terms. Right? Same 3 steps every single time. If you're not doing those 3 steps, you're making your life way harder.
Why did your denominator change from x plus 5 to x minus 5? Yeah,
It's invisible. There we go.
so now you can change MPV to negative 5.
There. Okay. Okay. Exactly. Okay. C. 5t over 2t plus 1 minus 3t over 4t plus 1. Now, you guys, 2t plus 1, 4t plus 1, can I make them be the same? No, I can't. Some people will say, well, I'll multiply this one by 2. If I multiply this one by 2, I get 4t plus 2. They don't match. Okay? So I have to multiply them by each other. That's what one. And then number 4, what if I give you this? X minus 5 over 3 plus 4x over x minus 2. So try these two out. Okay, so for number 3, we have to multiply this one by 4t plus 1. And this one by 2t plus 1. Just make sure we distribute our tops first, right? So we're going to get 20t squared plus 5t over 2t plus 1, 4t plus 1, minus 6t squared plus 3t over 2t plus 1, 4t plus 1. So our first step is get common denominator. We just did that. Check. Done. Right? First step, get common denominator. Second step, write over one denominator. So we're going to get 2t plus 1, 4t plus 1.
Repeat the 5.
Yes. Distributing. So we're going to get 20t squared plus 5t. Then we have to remember to distribute our minus through. So minus 6t squared minus 3t. Collect like terms. 20t squared minus 6t squared is 14t squared. Plus 5t minus 3t plus 2t. Over 2t plus 1, 4t plus 1. So we literally did get common denominator. Write over one denominator. Collect like terms. Right? Have I changed my steps? Any of these questions? No. Same steps. Get common denominator. Write over one denominator. Collect like terms. Last step I check if I can. Simplify and state non-permissible values. It's 4 steps. Have I changed them at all throughout all of this addition and subtraction? Not once. Same steps over and over and over. So, can I do something to this? I can take out a 2t, and I'm left with 7t plus 1. Because you're going to get 4t squared, take out a 2t, I'm left with 7t, right?
Yeah.
2t divided by 2t is 1.
Yeah.
And then on the bottom we're left with 2t plus 1, 4t plus 1. This time you have to try and stop yourselves from canceling the 2t's off on the top and the bottom. Why can't we do that? We can't. Because these ones are sewn together and these ones are not. Okay? And then we have to do our MPVs, and these are the ones that people stink at for MPVs. I'm promising you on the unit test, you'll have to find an MPV where you're going to actually have to get a fraction. You will. It's going to happen. Okay? How do I know that? I wrote the test. So I know that you're going to have to give me one that's a fraction. Okay? At least. So I go, so that I don't make a mistake, I can go 2t plus 1 can't equal 0. 4t plus 1 can't equal 0. Subtract the 1 over, so I got 2t can't equal negative 1. Divide by 2. T can't equal negative 1/2. Subtract 1. 4t can't equal negative 1. Divide by 4. T can't equal negative 1/4. So I have to fall behind with t can't equal negative 1/2 or negative 1/4. Okay?
Yes.
So we understand you're going to get a fraction MPV. You're going to. Don't be like, well, I really hope she doesn't give me one of those. She's going to. Because she is me, and I know what I'm doing. Yeah.
Turn up, drink water.
Yeah. So we're going to look at this one. I have a monomial, which is a 3. and I have a binomial, which is an x minus 2. Can I make them be the same? Can I make a monomial be a binomial and a binomial be monomial? Nope. It's a huge giveaway. If one of them is a monomial and the other one's a binomial, you're going to multiply them by each other. That's it. Because you can't make them be each other. So we're going to multiply this one by x minus 2. X minus 2. And this one by 3 and 3. So I'm going to rewrite it just so it's not so messy. So I'm going to go x minus 5 over 3 times x minus 2, x minus 2. Plus 4x times 3. I'm just rewriting it. You don't want to, doesn't matter. Okay, do I distribute my denominators? No. When's the only time I distribute my denominators? If they're both monomials, which means they don't have plus signs, correct? If one has a plus sign, you immediately are not putting them together. So I'm going to get 3 over x minus 2 in the bottom, plus 3 over x minus 2 in the bottom. And in the top, I'm going to have to FOIL. I'm going to get x times x, which is x squared. X times negative 2x. Negative 5 times x, negative 5x. Negative 5 times negative 2, positive 10. 12x. So, first step, get common denominator. Second step, write over one denominator. So I get x squared minus 2x minus 5x plus 10 plus 12x. So first step, common denominator. Second step, write over one denominator. Third step is what? Collect like terms. So I'm going to get x squared minus 2x minus 5x is minus 7x plus 12x is plus 5x plus 10 over 3x minus 2. Can I take anything out of my denominator? No. Can I do anything to my numerator? No, you can't actually factor and get you anything that's 5 from 10. What can I say? X cannot equal 2. Is it 0 as well? No, because this is just a 3, not a variable. I get zeros randomly all the time. And they're just not right.
It's not.
Pardon?
It's
If you put a 0? Yeah.
3 cannot be 0.
3 cannot equal 0, but x cannot equal 0 is wrong. So I'm saying people will put a 0 here, which is wrong. 3 cannot equal 0 is fine. Putting a 0 as your NPV is wrong. Okay?